All right, hydrogen sulfide can be formed in the following reaction. I give the equation, I give you a delta H, it's endothermic. Have an equilibrium constant of 106 at 273, and we want to estimate the K at 373. All right, so we have an equation where we're looking at two different Ks on the periodic table at the beginning of the test, or the one in class when we take the test. You'll see we have the equation that relates our two equilibrium Ks using the heat of the reaction over R, and then the two temperatures. The units are something we have to watch out for. You will want the temperatures in kelvins. They already are, but we're going to need to change the delta H. And to keep this convenient, I'm just going to go and call the 106 K1, and therefore we're going to solve for K2. So this is the 106. I'll put in the delta H as 171,000 joules per mole. The R is the energy one, so 8.314 joules per mole Kelvin. And then our two temperatures. So T2 is the one that would pair up with our unknown K, so that is the 373. And this will be 273. And now we're going to solve this whole thing. All right, so I'm going to start by solving everything on the right. So I'm going to start with the negative 171,000 divided by 8.314. Oops, too many ones. Times, in parentheses, the inverse of 373 minus the inverse of 273. Close those parentheses. That should be everything on the right. Now to get rid of the natural log, I'll take the inverse natural log of this. That value should be K2 over K1, so I'm going to multiply this by 106. Telling me that I should get a K2 of 3 significant figures 6.27 times 10 to the 10th.